right, this is section 14.1, page 5, on stem and leaf displays. So a hospital is testing 2 weight loss programs to determine which program is more effective. The following data represent the amounts of weight lost by comparable clients for a year in each program. Represent the 2 given sets of data on a single stem and leaf display. Which program seems to be more effective? Okay, so what we do is we look at the data and we say in program A, it looks like people lost anywhere between, what's the lowest? It looks like 19, all the way up 32. Do we have anything? 37, 47. We have anything beating 47? No. So it goes anywhere from 19 to 47. What about program B? See if we get any higher or lower than that. Nope, it doesn't look like it. So what we do is we make the stem the first number and the leaf the second number. So we're noticing our first numbers range from 1 to 4. So we're going to go ahead and write down 1, 2, 3, 4. Okay, and then we want to do program A and program B, and I didn't really leave us enough room. So let's do that again. Let's put it down a little further so that we have enough space. Okay, so I'm going to move it over a little bit here. 1, 2, 3, 4. Okay, so here on this side, we're going to write program A. And this side, we're going to write program B. Okay, we're going to start with B first just because it's easiest to do it this way. So we'll draw a line here. Okay, and then we're going to go ahead and write all the numbers down. So we see 29, so that already has its 2, you put the 9 there. And then 21, you put a 1. Now before you put the 1, you want to evenly space these because it's kind of critical that each number takes up the same amount of space to make this accurate. 39, we'll put a 9 down. 44, we'll put a 4 down with the 4. 41, you're going to put a 1 down. 36, put a 6 down on the 3 row. 37, put a 7 down in the 3 row. 26, put a 6 down, another 26, so another 6. Then 43, 3 goes there. Do you see how I'm lining them up? That's what we need to be doing. Then 45, then 28, then 32, then 28, then 33, then 36, 53, hey, didn't see that one, and then 39. Okay, so let's add here and make a 5 at 53. Okay, so that's what it looks like. So you're kind of turning your head here, or turning the paper and saying, okay, these are the people who lost 10 pounds in the 10-pound range. These are who lost in the 20-pound range, 30-pound range, 40-pound range, and 50-pound range. And what we want to do is compare that to the other program, program A. So we're going to go ahead and draw a straight line here. And we're going to do the same thing, only in the other direction. So when we do program A of 1, we put a 9 here. And again, we want to equally space them. 32, so that's in the 3, we put a 2. And then 27, we put a 7 on the 2 row. 34, we put a 4 on the 3 row. And then 33. And then 36, and then 47, and then 32, and then 25, and then 52. Oh boy, I really missed those 5s. And then 29, and then 26, and then 37, 28, 26, 43, 31, and 40. Okay, so when we look at this and we're trying to compare which program seems to be more effective, if you wanted to participate in one of these programs, which one would you go for? Well, let's count these up. We have 3 and 4, 7 there and 7 here. Okay, so these are the same. Okay, and these are the same. So what's different is, when I say the same, I mean there's 4 people in this one. There's 7 people in the losing 30-pound range. 6 people in the losing 20-pound range. But here this person has only lost 19. And here they don't have anybody in that range. So you're looking for what makes something effective, a weight loss program. You want more weight lost. So you're looking for more people on the heavy end. You want them to lose more weight. You want more 40s and more 50s. So here I see, well, I've got 4 40s and I've got 1 50. So it looks like program B seems to be a little better. They've made these too close in my opinion, but let's say program B seems to be more effective. So if I gave you an example, I'd make it real obvious. There'd be way more things down low here in the program B category. Okay, go ahead and pause and do your classwork, number 29, and then come on back. Hopefully you read that quote. There are 3 kinds of lies, damn lies, and statistics. And that's because, people manipulate statistics and sometimes don't follow all the rules. And here's a perfect example below. So if we look at example 4, comment on the difference between gas mileage for the 3 car models. When you look at this graph and you see, okay, the Honda gets really good gas mileage, Chevrolet not as good, and Toyota Camry, gosh, much worse. You might want to think, gee, did I know that? Did I know that there was that much difference between, let's say, the Honda and the Camry? Well, if you look at the graph a little bit more carefully, you'll notice that 36 is what the Civic gets, 34 is what the Chevy gets, and 31 is what the Camry gets. Those values aren't that different. It's the way that the graph has been displayed, and when we turn the page, we'll see what they're doing to us. Also notice, so it looks like here, what's our comment? I would say that the Honda gets much better gas mileage. Okay, let's see what comment we can make here. We're looking at the difference between passengers in 1984 and 2010. Well, gee, it doesn't look like there are very many passengers here at all, but boy, lots. So we would say in 2010 there are lots more passengers. And if you had to guess at a number, what would you say? Does it look like twice as many, 3 times as many? I think it looks like more than twice as many to me, more like maybe 3 times. Times as many. Okay, well, let's turn to the other page, our last page, and see if we have done this accurately, what it should look like. So I don't know if you noticed, but this graph started off at 30. So if we start the graph at 30, then the differences look great between these. Look what happens here. If we start at 0 and say, well, this one gets 36 and 34 and 31, look at how similar they look because you have the entire bar graph. So these are the types of things that can be done that deceive you. And can you really say that it's wrong? They've labeled it, but how many people look at those labels? They just look at the bar graph and make a decision based on the pictures. They don't really check out all the pieces. So you have to be careful about things. Likewise here, with this picture, here's a bar chart that starts at 0. So this would be not deceptive, okay? So when we look at this, well, we can see that here it's like 350, here it's like 700. It's only twice as much, although here it looks like 3 of those planes would fit into here, okay? So here, how are they deceiving you? Graph doesn't start at 0. And that's a common way to deceive. And here they've increased both length and thickness, okay, to make you believe that it's really more of a difference than what there truly is. All right, that concludes section 14.1. You can do your homework now and your classwork if you haven't completed it.